let's see. Yeah, so let's understand the problem statement. So you will be given an array and starting position, and you can move either I plus array of I or I minus array of I. You can move either of two directions. So we need to return true. If you closely see, given an array of non-negative integers, you are initially positioned at start index of the array. When you are at index I, you can jump to either I plus array of I or I minus array of I. Check if you can reach any index with value 0. So that's what the problem statement says. Let me explain. So let's say you have an input. Let me take some interesting one. Yeah. So let's say you have an input 4, 2, 3, 0, 3, 1, 2. So these are the elements, and these are the array indexes 0, 1, 2, 3, 4, 5, 6, and you are also giving start equaled 5. So it means if you move on to fifth index, either you can move, assume that in this case I equal fifth, so I plus array of I, or you can I minus array of I, or you can also move I plus array of I. So this is the condition. So if I move, I can move here. uh, so I so if you see, array of 5 means I am having value 1, so 1 plus, so sorry, 5 5 is the ith index, and in array of 5 means this is minus, so array of my I value is 1, so 5 minus 1, or I can move to 5 plus 1. So it means I can move to index 4, or I can move to index 6. So now let's look into this. So I am at index 4. So when I am at index 4, so I am at index 4. So when you are at index 4, so you can move to I plus 3 or I minus 3. So it means here I is 4, right? So 4 plus 3 or 4 minus 3. So if I move to 4 plus 3, so which is going to be out of the array. If I move to 4 minus 3, so I am moving here. So when I come here, now I am at I is equal to 1 here, right? So I can move to 1 plus 2 or 1 minus 2. So 1 minus 2 means out of the array, 1 plus 2 means I reach index 3. So whenever you reach an index, if it is holding value 0, you just return true. Otherwise, you can return false. So in this case, somehow you are able to, if you are starting from index 5, following this condition, I plus array of I and I minus array of I, and you are doing backtracking, and somehow you are able to reach an index which is holding the value as 0, so that you can return true. So let's take one more input. So you have 3, 0, 2, 1, 2. Now here start position is equal to, so this is the array. So let's look at the indexes. Start position is 2, so it means from here you can move to I minus 2, so it means you can reach to 0, or I plus 2, or you can reach to index 2. Okay, so it means index 4, so I can reach to index 4. Now from here you can reach to index 6, which is out of bound, or you can reach to index previous one, so which is going to be 4 minus 2, so which is again 2. Now if you go here, I can reach to 0 minus 3, which is out of bounds, 0 plus 3, so I can reach here. So once I reach here, so here I am. Now I am at index 3, so I can reach 2 plus, so 1 plus 3, which is 4, so out of bounds, or I can reach to minus, so again I can come to here, so I can again come to the 0. So it means if you closely see, you are ending up into a loop. You are not at all able to reach the index which is holding the value 0, so that in this case you can return false. Is the problem statement clear? Ajay Kalyan. Right, how do you solve it? How do you want to solve it? Let's take the input. Yeah, so let's take this input. So 4230312, and here the start position has given as 0. So how do you want to solve it? Any idea?
Shrinu, with the DP approach, basically we can do it by keeping a DP array where we will
What kind
give
of
the
D?
indexes which
Okay, so the DP arrays holds what? What it will hold?
uh, basically to track whether the indexes are visited or not.
Okay. Hmm.
That way we can do it.
If it is visited, then what do you do?
If it is visited, then we'll mark it as true.
Hmm.
So next time when I'm visiting again, if we see that there is a already visited,
Hmm.
so we can see that there is a loop basically coming in and we can come out of it.
Hmm. Then
Uh, so
so
basically
then you
whichever the
return.
index we're starting, right, from
Hmm.
there we will track left and right both.
Hmm.
So if it is within the limit, then we'll mark that node as true, like visited.
Hmm.
Yeah, that way I
Then
can think of, yeah.
how do you return true? Yeah, that is absolutely correct. So when do you return true? Because they are expecting true or false, right? So
That's true, yeah.
the
Each time
simple.
when you reach the index with the current index and its value, if the
Hmm.
the reached destination index value is 0, then we might return true.
Yeah, so yeah, that's the core idea. So whenever you want to check for all possibilities, right? So this is where you don't know which direction to you move on, right? You just went with the flow. You will just go with the flow, whatever condition which was given. So through which condition you just go with the flow, right? So that's where you must and should think about depth first search or recursion, backtracking, whatever you say. So let's say here my starting index is 0, right? At starting index I have value 4, it is holding index 0, right? So this is my first one. So what I'll do, I can move to, from this index I can move to left side or right side. If I move to left side, it is going to be index minus 4. If I move to right side, it is going to be index plus 4. So negative means, as you are moving on to, this is negative, right? So as it is negative, so that you don't need to process this. But if you are moving on to right, if you are moving on to right, if you closely see, you are moving on to index 4, right? It means you are reaching index 4. So if you closely see, at index 4 we have value as sorry, at index 4 we have value 3, index is 4. Okay, so I am just writing the index 4 in the brackets. Now again, if you closely see, you can do same process, right? So index means index is 4, right? So 4 minus 3 or 4 plus 3. So if you closely see, if you go left, definitely you are reaching index 1. So at index 1 we have value 2. Okay, so you have value 2 at index 1. Then if you try to move right, you will be moved, you are reaching 7, so which is out of bounds, right? So which is out of the size, so that you can ignore it. Perfect. Now I am at index 2, sorry, I am at index 1, which is having value 2. So that what is our condition? So 1 minus 2 or 1 plus 2, right? So index minus given value or index plus given value. If you go here, it is going to be negative. If I come here, I will reach to index 3. So if you closely see, from here if I take plus 2, so I am reaching index 3, which is having value 0, and I am reaching index 3. So whenever you reach value 0, right, it's blindly you return true. So once you return true, that's it. So all the recursion stack will stop. If you closely see, From here you went to negative, right? So this will return false. Now you need to track this. So when you are tracking this, if you come left, so you will get into index 1 with value 2. From here, if I come left, I'll get negative, so it is false. If I go right, it is going to return true. So the combination of true or false, which is going to be true. So this is true, and even if you go, of course we don't explore this, even this will, even if you explore, it will return false. The combination of true or false is true, and the combination of these true or false is true. Is this clear, buddy? So that we will return true. Is this clear?
Yes.
Now this will, here this is very good test case, so that you don't revisit same index again, right? So all indexes are unique, right? If you closely see, whatever indexes you have visited, all the indexes are unique. But let's consider one test case. So you will end up revisiting the same index again and again, so that it's, so we need to handle that. So let's say you have 3 0 2 1 2 and start equal to, so I am having values as 0 1 2 3 4. Okay, so now I am starting from index 2, right? So let's move on. At index 2 you have value 2 and index also 2. So I am here, so that what I will do, so let's move on. So now you can move on to index minus 2, index plus 2. Okay, because both are 2. It means if your index minus 2, so you are reaching index 0, which is having value 3, and if you are going on to right, you will reach on index 4, which is having value 2. Now again, if you closely see, I can move on to index minus 3 or index plus 3. Index minus 3 means it is negative, so that you can blindly return false. Index plus 3 means you will get into third index, which is holding value 1. Okay, perfect. Now again, if you go here, you can move on to left, so it means index minus 1 or index plus 1. So index minus 1 means again you will move on to index 2, which is holding value 2. If you go on to right side, it is moving on to value 4, index 4, which is having value 2. Right? Now if you closely see, you are again restarting the same process. So you reached here, right? And again, if you try to go left and right, it is like you are restarting the same cycle. Isn't it, buddy? So we are starting from same index, right? Yes or no? Yes or no, buddy? Yes or no?
Yes.
Yes. So it means what you should do, so whenever you are trying to process, first you mark that as visited. Okay, so let's do that. So what I am doing, I am starting from index 2 and it is having value 2, so that first I will mark this as visited. So I marked it as visited, so I went left and I also went right. So when I went left, so I get into index 0, it is having value 3, so that I will mark index 0 also true. Now when I go left, definitely it is negative, so that I will return false. When I go right, I am moving on to index 3, which is having value 1, so that which is not visited, so that I will mark it as visited. Now when I go from here, when I go left, I will again see that, what do you see? I am again going to the index 2. So when I am going to the index 2, I understand that which is already visited. So which is already visited, so that when it is visited, don't solve it again, so that blindly you return false. Okay, so as it is visited, so that I can blindly return false. Now if I go on to the right side, it means 3 plus 1, which is going to be index 4, so that at index 4, so we didn't visit it, so that first we mark it as visited, then we will try to look for directions. So from index 4, it is going to be 4 plus 2, it is going to be 4 minus 2. So 4 minus 2 means again index 2, which is having value 2, which is already visited, so that this will return false. 4 plus 2 means out of array size, so out of array size, which is also return false. So both will return false, so that it will return false. This one and this one return false, so that this value is also false. Both will be false, so that this will return false. Now when you go right, you are into, so 2 plus 2, you are into 4, so which is already been visited, so that you will blindly return false. So both are false, so that you can return false. Is that clear, buddy? Kalyan?
Yes.
So what is the time complexity here?
It will be 2n for false case and n for positive case, no?
Why it is 2n for false case?
It's n square, right? I think.
Why it is n square?
No. For false case, we'll be visiting.
How many times we are solving same index? Or how many times we are visiting same index?
Actually, only once. Actually, we are
only
visiting.
once.
Second time when we are doing it, it's already true or false based on the way taking call. It's
Yes.
order of n.
N only.
It is order of n, right? So what is the space complexity?
Order of n.
So why? Because we are using visited array, right?
This is definitely correct.
Yeah.
We are using visited array. Okay, so let me simply write it. So what we do, so we are going to take a boolean array of visited. So new boolean array of length. Okay, so now it's time for us to solve. So you can simply call can reach, passing the same array and the start position and visited. Okay, so can you tell me what are the base cases we need to consider here? Can you tell me what are the base cases we should consider?
The index reaching less than 0 and greater than n, we just ignore them.
Yeah, so what we should do that time? How do you ignore it? So it means index means here start. If it is less than 0 or start greater than or equal to array dot length. So what should we do?
Just continue it.
No,
If you
it's a return type, right? It is return type.
Yeah.
What are we doing when out of bounds? What are we doing in the diagram?
We are making false.
Yeah, so we should return false, right?
Yes.
It means you didn't find anything. Then what if my what is it? So nums of what is it? Is array, right? So array of star. If it is equal to 0, then you found a target, so that you just return 0. Sorry, return true.
True.
Otherwise, what you do first? Otherwise, what we should do first? We mark this as visited. So first we mark this as visited, so that this won't be revisited again. Then what is our job? Tell me, Ajay, what should we do now? So I should explore other possibilities, right? So start from the given index, start minus array of start, comma visited, or
condition
plus.
and the same thing plus start plus array of start.
So that's it. Tell me what is a mistake we did. Visited. Okay.
This is ending with a loop.
Yes, it is ending with the loop. So let's look at that. Just a second. The false case of this one, right? The one we discussed, which is ending with the loop. So what is a mistake we have done? So we have discussed the same thing. First we mark this as visited, then we went here. Let's move on.
Are we maintaining the visited array there?
Yes, we are maintaining visited array, and we are marking it as true. Okay, then what is a mistake we have done? Tell me, buddy. You must tell me
For
this.
for visited one, if it is true, then we need to return false there.
Right.
We don't need to.
So of course we are
look up
marking it
again.
as visited, but we are not checking it,
Yeah.
right? If it is already visited,
Correct.
so don't do that again.
Operate on it. Yeah.
So that's it. So this is the DFS code, right? Now how do you solve the same problem with BFS? Okay, so this is a depth first search. So what we did, so we just started from the given start index, and we are trying to move on index minus value, index plus value, and we figure that out. Now let's move on to breadth first search. So it's a very simple use case. So let's see how can we do that. Okay, let's take up the same input 302 212, right? Okay. So you have 302 1 2. Okay, these are the indexes we have 0 1 2 3 4, and start index is 2. Okay, so in breadth first search, simple. So actually whatever problems you could solve on depth first search, most of the problems you can solve with the breadth first search. So let's move on to breadth first search. We need to start from index 2. Okay, so it means in the queue I have index 2. So let me, for clarity's sake, I am holding both the values. So I am having at index 2 I have value 2. Okay, so this is my index 2. So this is part of my queue. Okay, now what is my job? So first I will mark this as visited. So this we should not forget. So okay, so we marked it as visited. Now what I can do, so I can move on to both directions. Index minus values means 2 minus 2 or 2 plus 2. So 2 minus 2 means what? You are moving on to index 0. At index 0 we have value 3 and the index is 0. And if you move on to the right side, it means you mark this as true, and because it is not visited, if you move on to the right side, 2 plus 2, which is going to be 4. So that so at you have value 2 at index 4. So you mark this is also visited. So now these two are part of the queue. Now what my job is? What is my job? So I need to process this one. So if I want to process, so 0 minus 3 and 0 plus 3. So minus 3 means negative, so that I don't add to the queue. 0 plus 3 means 3. So it means I am moving on to this. I mark this as 2. It is not visited, so that what I will do, at index 3 I have value 1 with index 3. So now this is going to be part of my new queue. Now let's move on to this direction. So index is 4, value is 2, 4 minus 2, 4 plus 2. So 4 minus 2 means 2. So index is 2 having value 2, but which is already been visited, so that I don't add to the queue. Now 4 plus 2 means it is over positive value, so out of the array, so that this is also I don't add. Now I have in the queue, I have only this one. So if I come here, so definitely what will happen, I get index 3. So it is going to be 3 minus 1 and 3 plus 1. So 3 minus 1 means you go to index 2, and 3 plus 1 means you go to index 4. So both are already visited, so that I don't add both of them into the queue. Now queue becomes empty. So as queue becomes empty, it means what? You will not find an index which is holding the value as 0. So whatever indexes you visited, all the indexes doesn't hold value 0, so that you can simply return false. So if it is a positive case, somewhere in the middle you will find an index which is holding the value as 0, so that you can return true. Is it clear, buddy? Is the BFS logic is clear? Maithili, is that clear for you?
I joined a while ago. I didn't understand the problem statement. I just watched recording.
Okay. So the problem statement is simple. So you will be given a start index. Either you can move on to start index plus value. So in this case, start index is 2, value also 2. Either you can move on to index minus value or index plus value. And when you are moving on to the associated index, if the index, whatever index you are moving, if that index holding the value as 0, you can return true, otherwise you can return false. In this case, we didn't visit an index which is holding the value as 0, so that we return false. Okay, so what is the time complexity, buddy? Ajay?
Order of n.
Kalyan, what is the time complexity? Order of n, right? Because here also we maintain visited. What is the space complexity?
I think
As
it's
it
constant
Is it constant? Can you think?
we are taking Q.
because we take the Q
Mm.
and we insert that element, but if it is already visited, we mark it false.
Mm.
We keep polling it all the time.
Mm. Let's say you have 1, 1, 1, 1, 1. Okay. So now you are
Hmm.
here. So you are here. So you can move left or right. So you will end up having value this one, right? And you are here. You can move right or left. You can end up having value this. Uh, Q size must not be n, but
It will be less than n, but not a constant. Yeah.
yeah, yeah, it is less than n, but somewhere it is going to be n by 4 or some kind of thing, so that you can mark it as n. Understand?
Hmm.
It is not constant
Order
at
of
the
n.
same time. It is not
Yeah.
n, but somewhere in the n. Okay.
Yeah, if we find 0, then we no need to insert all.
Yeah, yeah, that's the best case.
Mm.
Or can you write a logic for it, or let me do it. So we have visited. This is more important. Okay, so what is our job? So first we have a queue. So first we will add starting index to the queue, and we will mark that index as true. So once you're done with it, now it's time for us to move on. So this is my queue is not empty. I will just do it. So what is it? You don't need to worry about levels here, because we are not finding on which level you find 0. We just need to return true or false, so that you can blindly move on to the queue. So index equal queue dot pull. So somewhere, if you see that, if whatever index you visited, if it is something like what is it, nums array of start, right? So if it is equal to, sorry, this one, so array of index, if it is equal to 0, definitely you can return true. Otherwise, what you can do, so we will see whether index minus within that index whatever value you have. So array of index is what do you say, is greater than 0, greater than or equal to 0, and what do you say, yeah, definitely it should be greater than, you will always get a negative value only, no? So definitely it is greater than or equal to 0. If it is greater than or equal to 0, and if it is not visited, so what do you say, uh, so visited, if this index is not visited,
That index we can declare as a variable at the top because we'll be using that in both cases here.
yeah, anyhow you will be end up having the same thing. So if you see, this is greater than 0 if index minus index array of index greater than or equal to 0, and it is not visited. So first you mark this as visited. Okay, mark it as visited, and add to the queue. Okay, so queue dot add of index minus array of index. Okay, similarly we will also see other condition, plus index, if it is less than array dot length, and if it is not visited, then mark it as visited. Okay, and add that to the queue. Perfect. Is that clear, buddy? Any confusion here? Ajay, Kalyan, any confusion?
No.
So that's what we did, right? Index and related value, if it is greater than 0, we will add it. If it is less than n and it is not visited, first we mark it as visited and update it. That's it. So somewhere if you find true, then you will return true, otherwise you return false. Yeah, DFS code is more straightforward comparatively BFS. Even that will give you better submission rate. Okay, but you should practice both of them. Okay, so let's move on to jump game 4. Okay, so let's move on to this. Okay, so what he's trying to say is, yeah, this is very interesting problem. I have attempted before the session, but I couldn't able to solve it. But I understood what is the mistake I did, so let's implement that. It was given time limit exceeded. Okay, so what it is trying to say is you will be given an array. So let's say the array you are given was you will be given an array as 100 and minus 23 and minus 23 404 100 and 23 23 3 and 404. Okay, so this is an array. Let's take the indexes. It has 0 1 2 3 4 5 6 7 and 8. Okay, so these are the indexes you have. What the problem statement says, if you closely see the problem statement, the problem statement says you always start from index 0 and you can move on to next index or previous index if it is less than n or greater than or equal to 0, or you can also move on to jth index if current index value and jth index value are same and I and j are not equal, and we need to return minimum number of steps to reach to the last index. Okay, so let me tell you one thing. So let's say here this is the given input. You always start from 0th index. Okay, so I am starting from 0th index. Okay, so what the problem statement says, you can reach to the next index or previous index. Next index you can reach if it is less than n. Previous index you can reach if it is greater than or equal to 0, or you can also reach to the jth index where, let's say this is array, so where array of I is equal to array of j and I not equal to j. So both the indexes are not same and the values are same, you can directly jump to that index. So let's say here what I will do, so this is my, if you see, this is the constraint, right? If you closely see, this is my constraint. So from index 0 I will use this, I will find out some. So from index 0, if I see there is an index 4 which is holding the value 100. So according to the third condition, if the current index on future index not same and both are having same values, I can directly jump here. Okay, so it took one jump. Now from this index I can take forward jump I plus 1 or I minus 1, but what I will do, I will take previous jump. So because there are I minus 1, I plus 1 or this one, so I will take I minus 1 so that I can reach to index 3. Now if you are at index 3, so you can, if you see at index 8, right, at index 8 I am having value 404, so that I can directly jump to this because as per the condition, if both the values are same and indexes are not equal, then you can directly jump here. So if you closely see, within 3 steps I can reach to the last index, so that output expected is 3. And what is other answer? What could be other answer? You can always take one step at a time, I plus 1, 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 I plus 1 and I plus 1. You will always end up reaching the last index. But in this case 1, 2, 3, 4, 5, 6, 7, 8. So it will take 8 steps. But we need to return minimum steps, right? So that minimum steps count we should return. So minimum jumps. So you can say minimum jumps. So which is going to be 3. So is the problem statement clear? Maithili, Kalyana, Jay.
One question, from 0 to 4th index, how do we directly jump here?
So that's what in the problem statement says, right? So in
If it is same,
yeah, if both the
same.
values are same and indexes are different, you can directly jump.
Okay.
So you can take any one of the choice. Either you can take I plus 1, I minus 1 or this choice.
Okay.
So
Got it.
first time I chosen this choice because both the indexes values are same, so that I went to the fourth index. Now from here I can move to forward and backward also, but I moved to the backward direction. So if I move to the backward direction, I reach to the 404. Okay, so it means from here once jump, here two jump, then now I am at index 3. So now I can reach to the index 8. Why? Because both are having same values, so that I can jump here. So this is going to be 1 2 3. So within 3 jumps I can reach to the last index. Is the problem statement clear, Ajay? Okay, now first thing is can this be solved with DFS or not? So that's the first question we should ask. Let me take one simple input, then we will see the possibilities. Let's say I have value 100. Let's take value 10, 20 and 10, and 30. 20 and 20. Okay, so what are the minimum jumps I require here? What are the minimum jumps I require here? So first I will jump here,
So,
and I will jump here, then I will jump here. So you always start from index 0. Okay, so that's the start position. The start point is always going to be 0. So that again it is going to be 3, right? First, can you tell
Yes.
me, can this be solved with depth first search? So first of all, DFS, right? It cannot be solved with DFS. Why? Why, can you tell me?
Because you don't know like where the duplicate of this have to traverse to the same element whether it exists. Otherwise, you'll always end up, traversing each and element using I minus one, I plus one.
Hmm. Okay, that is fine. Then why it can't be solved with DFS? So one thing for sure, right? So if you want to, definitely, if you don't maintain visited array, right? If you don't maintain visited array, you will end up getting into the same index again and again, right? So that you will maintain a visited array. And secondly, uh, it's we need to find out min jump, right? We need to find out min jump length. So if you want to find out a min jump length, so what is our job? From a given index, what is the minimum value you could get? That is also to be maintained, right? Yes or nobody? If you closely see, we have solved a lot of DP problems, right? So how generally DP works? For example, you are at index 0, and if you are moving on to index 2, and then you are moving on to index 4, so assume that index 4 is the last index. So it means from index 2 to index 4 you will take only one step. Let's say, okay, so what is the valid output here? Is it 2 or 3? What is the valid output here? Is it 2 or 3? Maitri, actually you pointed out, is it 2 or 3?
yeah, 2, because first 10 to 20 it can jump,
Yeah,
and then 20 to 20.
it can jump, right? So it can be 20 to 20, so it is going to be 2, right? So definitely it is going to be valid thing, right? Now, actually, let's say what is happening here, it cannot be solved with DFS. Why? Because uh, let's say uh, let's say I'm at index 0. Okay, so I'm at index 0. So index 0 is not solved, so that I'm trying to solve index 0. If I want to solve index 0, so there are two possibilities. I can directly jump on to whatever value this index is holding. So 10 is also present at index 2, so that I can move on to index 2, or I can move on to index 1, right? I can move on to index 1. So these are the two values I can do. So let me solve index 2. So if you closely see from index 0, first what I am trying to do, closely observe. This is very critical part, so that in future you can easily identify few of the problems you can't solve with DFS, though you can able to solve, though you can able to traverse. So what is happening? I am at index 0. From index 0, I can take one jump to index 1 or one jump to index 2, right? So definitely what is going to happen? So from this, I am going to take one jump to move on to either of the index. Now let's move on to index 2. Okay, so what are we doing? So this is a DP array, right? So definitely you end up definitely you don't want to solve the same problem again and again, so that definitely you will keep all the values into DP array. So our DP array is holding completely null values. That's why index 0 not solved. You are trying to get into index 2. Now index 2 also not solved. So what you can do? So there are two possibilities. Either you can move on to I minus 1. So it means index 1, or at index 2 you have value 10. Of course you don't backtrack, so you will take care of that. So you can't move on to future, or you can move on to I plus 1, so which is going to be index 3. Right, so now index 1 and index 3 also not solved. So what you can do, somehow you can move on to left. So if you move on to left, it is index 0, or you can move on to right, it is going to be index 2. So somehow you maintain a visited array, so that as it is visited, whatever nodes are visited, so you don't consider again. And one more thing is what, from index 1 you can directly jump on to index 4, because index 1 value and index 4 value both are same. So each time what you are doing, when you are traversing down, so you will just add plus plus plus. Now if you closely see, from index 1 to reach index 4, I need only one jump, so that I will hold that value. Okay, so this is 1. And from index 2, if I want to reach index 4, so from index 2, if I want to index 4, I need two jumps, because what is happening? So from index 2 you can come here, from here you can go here, so I need two steps, so that I got 2 here. I'm not traversing everything. So let's see. Now I am at index 0 and index 0, so this direction was given 2, so till here I got 2 and plus 1, so which is going to be 3. Now I am at index 1, so index 1 is already been solved. Index 1 was given value 1, so 1 plus 1 2, so it was given minimum of these two values, which is going to be 2. Of course this is giving valid answer. Generally what are we trying to do? So we are trying to explore all possibilities based on the given condition, and we will try to see what is the minimum value we could get. But this case is valid. This case is working as expected, because why? Because I am not so if I go this way, this will obviously give longer answer. That's why it is working. But what I'm trying to say, if you apply same concept on this array, definitely it will fail. Why? Because when you are working on, so you have an index. So this is my index. So you have an index. This index is reached with multiple directions. So this is, let's say this is index k. You can be reached from I, you can be reached from j. But generally if you reach this index k through j, it is going to be minimum jump. If you reach this index k through I, it is going to be maximum jump. So somehow what you do, so first you will solve this problem with I. You will try to solve it, so that you will get a maximum value. When with j, when you try to revisit it, you don't solve it again. Why? Because which is already been solved, you will return that max value, so that you will end up getting the maximum value. Do you understand what I'm trying to say, Ajay, Maithili? Is it confusing? So generally what I'm trying to say, if I take this input, it will work, but it will eat up our time. But what you do, you try to explore. Of course I will end up writing the BFS code, it will work, and you will try to convert that BFS code into DFS. Definitely you will not get valid result. Why? Because we are trying to maintain a DP array. It means once we solved an index, if we solve the if we solve the index, or if you solve the index, we don't solve it again. But to reach this index, right, there are multiple directions. One can be I minus 1, one can be I plus 1 can be array of I is equal to array of j. So there are three directions. When you are getting on to three directions, when you move on to particular direction, you will get a shortest path. But if you choose for other two directions, if you solve any one of other two directions, you may get longest path. And when you try to solve for shortest path, you already solved that index, so that you blindly consider that value, because you don't want to end up solving same problem again and again, so that you may get invalid result. In this case, I took a valid input so that it worked, but if you try for this input, definitely it will not work. Is it clear what I'm trying to say, Maitri?
Yeah.
So now let's say, how do you want to solve it, right? How do you want to solve it? So generally, whenever you want to find out a shortest path, right, you always go with BFS. So guarantees BFS always guarantees the first visited node is always going to be found in shortest path. So let's say you are starting from index 0, right? I am at index 0. One thing for sure, before getting into BFS, what are the things I should take care of? Can you tell me what are the things I should take care of? So I am having 404, right? So 404, it is at index 8. So there are three directions I can take, right? So I plus 1, I minus 1, and array of I, which is equal to array of j, and I not equal to j. So there are four directions I should take, three directions I should consider, right? So then what should I do? So this is very clear. From a given I can easily traverse forward and backward, but this is very critical, right? How do I identify in future index is present here? How do I identify that? Tell me. How do I know that there is a future index which is holding the same value? Maithili, Ajay.
Take them into a map. We'll do that, no?
Yes, no. So first what we should do, first we will maintain a lookup map. Okay. So let's maintain a lookup map. Let's maintain a lookup map. So what is my lookup map contains? So you have 100, right? So this is my map. 100 is at index 0 and 4, right? 100 is at index 0 and 4, and you have minus 23. So minus 23 is at 1 and 2, right? And of course you have 404. 404 is at 3 and 8. And what else? You have 100 is already done, and 23 is at 5 and 6. And you have 3 is at 7. So this is a simple map. So what we do, first we will construct a map, so that will help us to find out what could be the future index. So ideally, where should I start from? Ideally, where should I start from? Zeroth index,
Zero
right?
index.
So zeroth index, right? So now let's carefully see here. So I am at zeroth index. So let me short on this. How to make it short? Okay, let me try here. Okay, so I need to start from zeroth index, right? So I need to start from here, so that first of all I will be having index 0 in my queue. Okay, this is my zeroth level. I am at zeroth level. Okay, so I am at zeroth level 0, right? So I am at index 0, so I can take three directions, right? So one is I minus 1, I plus 1, another one is I need to find out index which is having the values, right? So I minus 1 means minus 1, I plus 1 means plus 1, and obviously you can have one more value. This is a map, right? From map I could see that there are two values, 0 and 4. 0 is the currently visited element, so that I don't consider 0, so that I can directly take 4. So it means if you closely see, from level 0 I can move on to two indexes, which can be 1, 4. Till now it's clear, right? Correct na? Till now it's clear na? Ajay, Maithili, Kalyan. Right? There is no complexity, right? So we are at index 0. So we should start from index 0. At index 0, I have value 100. As per the problem statement, I can move on to I plus 1. I can move on to I minus 1, or I can move on to array of I, which is equal to array of j index, where j and I not equal to j and I not equal, right? So in this case, I minus 1 is negative, so that we don't consider. I plus 1 is positive, so I plus 1 means 0 plus 1, it is 1, so 1 is considered. And I also find two indexes with the same value, but the first index is I equal to j, right? So currently I and j both are same, so that I don't consider this one. So that the second index 4 I can consider. So it means from level 1 I found these values, correct? Correct na buddy? Correct na? So this is level 0, and by coming to level 1 I found these values. Now let's move on to level 1, okay? So as you processed this, as you processed current element, you delete it from the map, because you already consider the current element in all the indexes, right? So this current element is at 0th index and 4th index. 0th index you already processed, and 4th index is going to be processed in future, so that you delete from the map. Okay, so you delete it. While writing the code, I did that mistake, so it went into time limit exceeded. So if you closely see, I understood by looking at the test case. So this guy was given very intelligent input, so that's where it went into time limit. I will explain why to delete it. Let's move on. So let's move on. Now I am at level 1. Okay, so I am at level 1. So when I'm at level 1, I need to process two elements, right? Yes or nobody, please? I need to process two elements. Correct, nobody?
Yeah.
Right? Right. So I need to process two elements. Okay. Let me. Okay, so let it be. So now let me process this guy. So if I go on to index 1, so I can go on to I minus 1, which is going to be index 0, I plus 1, which is going to be index 2. Another one is array of I value. So I minus 1 is at index 0. Index 0 is already processed, right? So how do you know that it is already processed? How do you know that it is already processed? I should not consider
So to
index
maintain
0.
a visited list.
Do we necessarily need to maintain visited?
Oh, in the map we
How
have
many
already
visited you
included
will
value.
maintain it, because there are duplicate values, right? So if you maintain it, yeah. So one way is you can maintain a visited array, visited
Index
set.
we can maintain, right? Not
If
value.
you maintain
Yeah.
indexes, then it's a problem of solving same problem again and again. That's exceeded here, right? So,
Correct.
Yes.
so what is happening here? We already solved whatever. So at index 0 you have 100, right? At index 0 you have 100. 100 is pointed by two indexes. It means whatever value which is stored at index 0, which is already present in previous level, so don't add into next level again. You understand my point? Right? So first what we did, buddy, so at index 0 we have value 100, right? So we understood index 1 value is added, and index 0 pointed value is 4, so which is also added. So what we did, whatever indexes you want to target for 100, which are already been added in the previous level, right? So it means in the previous, if you move on to I minus 1, you get into index 0. At index 0 we have value 100, which is already been taken care. How do you know that which is already been taken care? If it is not part of the map. Is that clear? Is that clear, buddy?
Yes.
Maithili, are you clear?
Not really, actually.
So what are we trying to do? So what is our job? What is our end goal? We need to find out a shortest path, right? If you want to find out a shortest path, uh, so if you want to find out a shortest path, let's say I have 10, 10, 10, 10. What is the shortest jump you can make?
1.
Why not 3? Why not 2 or why not 3?
Because all are same.
No, there are possible solutions, right? But why are you saying only one? So it means there are possible solutions, right? So I can take this way and this way and this way. This is one direction. Or I can directly go here, and from here, this is one more direction, and I can directly go here. This is minimal direction, right? So this is one. If I go in this direction, it will go into, it is output is going to be 2. In this direction, the output is going to be 3. But why are we saying only one? Because we need a minimum jump, right? Correct?
Yeah.
We need a minimum jump. So what does it mean? What does it mean? So it means when for a given value, you have 4 indexes, right? 0, 1, 2, 3, right? For a given value, you have 4 indexes, right? All these are indexes, no? 0, 1, 2, 3, right? So for a given value 10, you have 4 indexes. So in this case, it is fine. You don't know what you always want to get optimistic result from a given value, right? Right? Whenever you start from a given index, for that value, you want to know optimistic result. So if you want to know optimistic result, you will uniformly consider it as a single unit. Correct, no? So what will happen here? So if I apply the same concept to this queue, so what will happen? Initially in the queue, you will have index 0, right? You will have index 0. Index 0 having value 10, and this is level 0. Index 0 having value 10, and this is level 0. Now if you closely see, index 0 is holding 3 pointers, 3 references, so that for the next level you will have 3 references, 1, 2, 3, right? So what you did in level 0 itself, whatever possibilities you could explore for with value 10, which are already been covered, so that you delete it from the map. So once you delete it from the map, and this is going to be my level 1. So in level 1, so if you closely see, you can go left, right, and bottom, but if you go left, you will get index 0, and index 0 is holding value 10, which is already been solved, right? Which is already been solved or not?
Yeah.
How do you know that which is already been solved? Because which is not present in the map. Once you taken that and add it to the queue, so this is first 0th level queue, this is first level queue, then this is q0. Once you add it to the queue, so it means for 10 you already consider it, so that this will not consider. So left you won't consider. Right, do you consider right? So if you go on to right, you will get in value 2, and so value 2 means index 2. So from index 1, if you go left, this is right, and this is somewhere on the mid. So let's talk about left. If you go on to left, you get value 10, which won't be considered because which we already consider in the previous step. And if you go on to right, and again you will have value 10, so we don't consider because which is already solved in the previous step. And similarly, if you move on to the, if you want to look for future index for this, you don't consider it because which is already been considered in the previous step and deleted from the map, so that this will not add any value, and this will also not add any value, and this will also not. So yeah, right, so 2 also doesn't add any value because when you go right left, you will again get 10 10, so that this will not add any value. When you come to 3, right, when you come to 3, so first you pop this, then you pop this, then you will pop 3. So when you pop 3, now you understand that which is equivalent to array dot length. So it means within the first level itself you found a result, so that you can return that level value, so which is 1. So that's the expected output. You understand? So what are we trying to do? So we want to find out a shortest path, right? So if you want to find out a shortest path, we need to see what could be the possible valid solutions you could make, right? So what are the possible valid solutions you could make? So before jumping into algorithm, let's look at how it can be solved. So you are at index 0. So when I'm at index 0, I can add, if I go left, I will get negative, so that I don't consider. I will go to I plus 1. So I plus 1 will return 1. And I'll also go, I will also move on to next index, which is going to be 4, the future index, which is going to be 4. Okay, so this is what, this is level 0, and this is level 1. Now I am at level 1. So when I am at level 1, I cannot move on to the left because which is already visited as per your knowledge. I can move on to the right. So I can move on to the right, so which is going to be 2. I can move on to right, which is going to be 2. And if you closely see, even if I look for z value also, which is also 2, okay, let's consider it as 2 comma 2, that's fine. And when it comes to 4, at index 4 we have value 100, so that left I can move to 3, right I can move to 23. So 3 means index 3, right I can move to index 5. Okay, now this is level 2. So now I am trying to process these two. Then when I am trying to process this value, right, so this index, right, so at index 3 I have 403, so I can move on to left, which is index 2, which is already visited, so that I don't consider it, because in the previous step we visited. If I move on to right, which is 4, which is also visited, so that we don't consider. And 404 is also having targeted value, which is 8, so that I can consider. Now when you are moving on to level 3, so you already got a target index 8, so that you can blindly return level 3. Without getting into algorithm, do you understand why we are getting answer 3 here? Ajay, Kalyan, Maithili.
Because of the level, that's the value we're returning, right?
Right, so level is the value we are returning, because we want to find out a shortest path, right? Okay, so let me explain. I think you are not getting it into, you are not getting conceptually, right? So let's move on. So what we are trying to do, let's explore all possibilities. I am at index 0. Okay, so I am at index 0. So index 0, so that index 0 is visited. Okay, let it be true. Now index 0 visited, so that I can move on to 4 directions: I minus 1, I plus 1, and a of I, which is equal to a of j. So these are the 4 directions. I minus 1 negative, so that I don't consider. I plus 1, so definitely 1. So this one, right? Let it be. Okay, so this is I plus 1, and this is a of I, which is equal to a of j, and I not equal to j. So this condition we are trying to solve. So I plus 1 means definitely 1, so I will take 1. Now if I move on to a of I equal to a of j, so let's see, I found a index somewhere here, so that I will consider this 4th index also. So it means from here I took either this one or this one. Okay, so let's move on. So I got this is considered as a single jump. Okay, this is considered as a single jump. Now let's move on to next level. So this is level 0, and this is level 1. Okay, at level 1 I need to process these two indexes. Now if you closely see, so whenever you are adding to the queue, let's say you are marking it as a visited, so that you are adding 0 is already queue, so which is visited, 1 you added, and 4 also added. So 3 are being visited, so that you don't reprocess it again. Because if you're trying to reprocess same result again and again, right, so it will exceed to the time limit exception. You end up solving the same problem again and again. So now I'm at index 1, so that I can move on to similarly I minus 1, so which is 0, which is already solved, so that we don't solve it. I plus 1, so which is going to be 2. Okay, so index 2, so that I add to the queue, so that I will mark it as true. Then at index 1 we have value minus 23, so which is already been added to the queue, so that because which is marked as true, so that you don't add it again. Now it means you are done with all possibilities, I minus 1, I plus 1, and both equal. Now when I come to the 4th index, so this one, so this is the 4th index. I minus 1 means what? Index 3, so which is not solved, so that first mark as true, add that index 3, and I plus 1 means index 5, so which is also not marked as true, so marked as true, and 3 5. So if you closely see, at level 2 I have these 3 values, right? I have these 3 values. I need to solve these again. Now from 2, I minus 1 I can go, I plus 1 I can go, and this condition also I can go. Let's see, at index 2 you have minus 23, so I minus 1 means which is already solved, I plus 1 means which is also solved, because you marked it as true, and minus 23 value also minus 23, so which is also been solved, so that this doesn't add any value. Is this clear, buddy? Till now, is this clear, please? Is this clear, buddy?
Yes.
Maithili, is that clear? Okay.
Yes. Yes, Srinivas.
now I am at index 3, right? So index 3 means again you will try to apply same thing. So I minus 1, which is also true because this is I minus 1. So if you closely see, so at index 3, so this is I minus 1, so which is also true, I plus 1, which is also true. And also at what is the target value? If you closely see, you found a target value here, right? So you found a target value, so which is 8. So it means you are trying to add 8 to the queue. So from index 3 you will only add one value to the queue. Okay, so it means you are only adding one value to the queue, which is 8. It means you mark this as visited again. Now you move on to index 5. This is also done, this is also done. You are also index 5. At index 5 you have value 23. Index 5, is it added earlier? Okay, yeah, I need to process this, right? So at index 5 again you need to apply, previous is 4, next is 6. So I need to mark this as visited and mark next is 6, and the matching value of index 5 also 6, so that you just consider it. Now when you move on to level 3, these are the, so first level you visited these indexes, second level you visited these indexes, this is the third level. So when you are popping the third level value, right, you got 8, which is equal to array dot length minus 1, right? So you can blindly return the level which you got. So it means what are you trying to do? You want to find out shortest path, right? You want to find out a shortest path to reach to the target, so that you can done with the BFS. So what are we trying to do? We are trying to explore all possibilities. So when you are trying to do DFS, right, when you are trying to DFS, you don't know when do you get the optimistic result, right? Because you are trying to explore all the possibilities. But when you are doing BFS, right, you keep on moving on level by level. Okay, so there can be longest path to reach this. Somewhere in the middle also you can reach it. So when you are moving on breadth first search, you can find the result is always in the shortest path, so that whenever you find a result, you can simply return that level number. Do you understand the concept, or is it confusing? Yeah, Jay, tell me.
So that concept understood, but I have one more doubt here. So in this example itself, for example, let's say from index 3, okay, we made a direct jump to index 8, okay, that way we found the result. What if in between we also have a value 404, let's say at index 6?
Still it is
So
fine,
in
right?
that case,
Still it is fine,
sorry?
right? Because
Yeah,
assume you
So
get first 6,
how
then
it will know that which is the shortest path?
because the most confusing part is we solve all the elements as a single unit, right?
Yes.
Of course, in this case also it is same, right? If you can reach from here to here, and from here to here, and what are the so in this case also same, right? For example, if you solve 6 first, 8 come next. Let's say it is 6 comma 8, right? 6 will add some of the elements, but 8 will not add, because 8 is the last element, so that you return 3, right? You all the elements present at level, we solve it as a single unit, na? Isn't it? So if you are solving it as a single unit, then there won't be any issue, right?
But the question Ajay asked, I think at 6th index, even if you get 404, we need to reach the last index, right? As per the question.
That's what I'm saying, right? So when you are at 404, you are adding 6 and 8 both to the result, right?
Correct.
So that you will visit 6 and you will also visit 8 on the same level. So when you visit 8, then you will return 8, right? So this is what we did here.
Got it. Understood, Shinu. So basically, what are the results we'll be getting? Can you go back to that?
So when you have multiple solutions, right? You don't know what could be the optimistic path. So what you do, you will see, okay, if I go in this path, do I reach? In this path, do I reach? In other path, if I reach, then this is my shortest path, so that I can directly return it.
Basically, we need to 6, 8. If there is another value 10 also,
doesn't matter.
Then 10 out with the result. Yeah.
It doesn't matter, right? So let's say you have 1, 2, 3, 5, and 8 in the same level. Doesn't matter. Even if you explore these, this will add couple of elements to the queue, but to the next level. But in the current level only you got the data, right? So that you can return the output, right?
Got it. Yeah.
Yes, as we are adding identical elements to the map, that
Yeah,
will take care
we
of
are
this
not
levels
we
and
are not solving the complete queue, right? If you get the target, you that is going to be your shortest path. So you will return that shortest path. Maithili, is it confusing? Okay. Okay. So let's this will work. This will work. Okay. Whatever algorithm we discuss, this will work if you simply follow visited array concept. But if you have huge number of repeated values, right, you keep on adding I plus 1 and I minus 1, and you keep on solving same, so it will lead to the time limit exceeded exception, because if you closely see, it was given same value, right? So you keep on if you don't delete that from the map, right? So that's what I'm trying to say. You have 1 million, let's say you have 7, you are trying to starting from 7, you are trying to have 1000 indexes mapped into the 7, right? Now you are at 0th index. So first you solved you added all these indexes, okay, all these indexes to the current level. Now when you move on to the first index, if you don't delete from here and you again add, of course you may eliminate 0th index, but you may add second index to remaining 1000 indexes. All these indexes will be added in this level, right? But if you closely see, which are already been added here, right? So if you add again, it will keep on accumulate your queue, so that will resulting into time limit exceeded. So it will work for smaller inputs, but when the duplicate values are more, right, if you try to add it again and again, so it will lead to the time limit exceeded. So now what we are trying to do, so first what we do, so we are going to apply BFS logic here. So we are going to apply BFS logic here, but we will do some intelligent operation here. So let's move on. So first thing is we will take a map. So we have 100, which is at 0 comma 4 index, and we have minus 23, so which is at 1 comma second index, and we have 404, which is at 3 comma 8 index, and we do have 100 is done, 23, so which is at 6 comma 7 index, and we have index 3, sorry, value 3, which is at index 7. 23 is at 5 comma 6. So this is the map. This is clear, right? This is clear, Ajay? This is map, right?
Yes.
yes.
So now we are starting from index 0. Okay, closely understand. So we are starting from index 0. So when you are at index 0, you have value 100. Okay. So now index 0. So first let's take up whatever. So index 0, you can move on to the left. Left is negative, so that you don't consider. Move on to the right. So right is 1, so that you will have index 1, and you will also add equal value, right? So equal value, the equal value you can consider from here. So what do you do? So what is the condition? A of I should be equal to A of j, and I should not equal to j. So in this case, this is equal, so you don't consider, then you will consider 4. Okay, so you added 1 comma 4. Okay, so this is level 0 and this is level 1. Okay, at level 1. So once you, if you closely see,
Dino, I have a question.
yeah.
If there are multiple indices, like 100 might be present in other places as well, maybe 7 also 100 could be there.
Yeah, this is what you are talking about, right? Let's say 10 is present in multiple places.
So then I think the last index, the highest number index we should take, right? That's the longest jump that it
How
can
do you
take.
know that? How do you know that? Let's
We are
say, let's
studying
say,
index,
let's
right?
say this way. I have 10, 10, 10, okay, 20, 10, 15, 20. Okay. So if I do this direction, right? As per your direction, this is the what you are trying to say, right?
Yeah.
Okay. 10, and this is one direction, and this way I can reach, right? Right, as per
Then
your
it will be
logic.
yeah.
As per
But
your logic.
ideally it is 2. I understood because uh,
Ideally,
no,
is it 2?
even
It
then it
won't be
will be
2,
3,
but let
right?
me take valid input. For this input, it won't be 2.
Yeah,
Let
it
me
will be
take,
3 in.
let's say I have 15 here, and
Hmm.
here I have 20. I'll also take one more value, 10 comma 5. Okay, so as per your logic, it should be something like this, right? It come here, and it may go here or here, doesn't matter. It may go here and it may go here, so it will give 3, right? So but actually, what is the valid output? So here it is giving 3 only. Let's take one more value, 16 comma 20. So as per your input, so it come here, or okay, so let's go this one and this one, right? So out, as per your logic, it is 4, right? Correct now?
Yeah.
But what is the valid output? So this is the valid output, right? This will return 3, right? So you don't know which direction you will get shortest path, right? Of course, if you blindly go for last element, that may give longest path.
So then in the tree, are we
so
going to consider
what is going
all
to happen?
the
Yeah. So what is let's take this input, so that it seems to be. Let's take this input. So initially this is at index 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So 10 is at index 0, 3, 5, right? So these are the 5, and you also have 5 is at only index 1, and 20 is at 2 comma 8. What else we have? 15, right? So 15 is at 4 comma 6, 16 is at 7. Okay, so now we start from index 0. So when you are starting from index 0, so I am at level 0, right? So to the next level, what I will do, so I will go on to left. So if I go on to left, it is negative, so that I don't consider. If I go on to right, I will have value 1, and whatever possible matching values, so I have possible matching values 0, 3, 5. 0 I should not consider because I am at 0 only, so that I will take 3, 5. Now this is more critical part. So once you are taking this, you will delete it from the map. So what I am trying to say is, you don't know which direction you will get a shortest path, right? Either you take a direction that from index 3 or from index 5. You don't know which direction you get a shortest path. That's why you will consider all this as a single unit. Understood? I will consider all this as a single unit. How do I map this as a single unit? Based on level number. It means first I took one path. It means from 0 I took one path. I get into index 1, 3, 5. Now let me think about, let me try to solve this. Okay, so let me try to solve this. So this is one path. Is this clear till now? Is it clear, buddy? Please.
Yeah.
From
Yes.
index 0 I get in 1, 3, 5. Now let's move on to 1. If I move on to 1, so if I go left, I will get 0, which is not present in 0 is already been solved. How do you know that? It is not present in map. How do you know that it is not present in map? A of 0 value is 10, so 10 is not present in map, so that it is already solved. So if I go right, I will get 20. Okay, so if I go right, I will get 20, so that 2 will be added. So 2 is present in map, so which is not solved, so that you added index 2. And index 1 having value 5, so there are no matching value 5, so that's it. So we are done with 1. Now let's move on to index 3. Index 3 having value 10, right? If I go left, I will get value 20. Okay, so if I go left from index 3, also I can take left now. If I go left, I will get value 20. So 20 is present in 2 indexes, 2 comma 8, right? Yes or no, buddy? Yes or no, please? 20 is present in 2 indexes now. Yes or no?
Yeah.
Yes.
Okay, sorry, it's not like that. So when you are at index, so this is what we are trying to do, right? So let me not be confused. So we got 2 here. Now we are trying to take left, right, and the target, right? So left means blindly you will consider 2. Okay, fine. Then right means you will consider 4 index 4. And what else you can do? And you can also take one more direction. So is it 10? Right, so this value is present in map or not? It is not present because we deleted, so that doesn't have. Now let's move on to done. So let's move on to 5. So when you move on to 5, let's say when you move on to 5, left means 4, okay, right means 6, and 5 is having value 10, which is already been solved, so you don't consider. If you closely see, from index 3 I took directions 2 comma 4, correct, so 2 comma 4, and from index 5 also I took direction 4 comma 6, from index 1 also I took direction 2, correct na? Till now is it clear? Is it clear, buddy? This is what I took. Okay, your Maithili, is that clear? From index 5 I went left and right, I got 4 comma 6, right? So 4 comma 6 is added. Maithili, is that clear? You are on mute. From index 3 also I took right and left, so which is 2 comma 4, so which is also added. From index 1 I cannot take left because which is already been addressed. I can take right, so 2, so 2 is there, so 2 is also added. Is this clear till this point?
Yes.
Okay, so it is clear. Now it's time for us to solve this. So I am at level 2 now. Okay, so now what I am doing, so this is my level 1 and this is my level 2. It means path 1, path 2. Now I am going on to path 3. Okay, so let's move on to index 3. Okay, so when I'm at index 3, so let's close this C. So index 3, so first I am holding value 20, right? Okay, so let's go on to 20. So 20, left is 1, so of course whenever you process you delete it from the map. So 5 we processed, in this case we processed 1 3 5, right? Index 1 is index 1 value is 5 and index 3 value is 10, which is also deleted. Index 5 value is 10, so which is also deleted. These two are deleted. Now I am at index 2. Okay, so index 2 is having value 20. Okay, so it means from index 2 you can move on to left, so which is 1, you can move on to right, which is 3, and you can also move on to the associated indexes. So index 1 is having value 5, so which is not present in map because which is already been processed, so that we don't consider it. And right is having 10, so 10 is already not present in map because which is already part of our queue, so that we don't consider it. Now let's see index 2 equal to 20 equal to 20. So okay, so this is the target. So we have indexes 2 comma 8. 2 we won't consider because current process is 2, so that we will consider 8. Okay, so we added 8. Oh, it means once you are done with solving this index 2, so you delete it from the map. Done. We are deleting it from the map. Now when you are trying to solve it, when you are trying to solve index 2 again, now if you closely see, which is not present in map, so that you don't need to solve it again. So if it is present in map, then only you solve it, otherwise you don't need to solve it. Now I am at index 4. When you are at index 4, you can move left, you can move right. If you move left and right, which is already been solved, and for index 4 the target value is 6, so that you can consider 6. Perfect. And second time when you visit, so index 4 you have value what? Index 4 you have value 15, so we deleted it. Second time when you visit 4 again, you don't solve it again. Now when you move on to index 6, so index 6 is having value 15, which is not present in the map, so that you just delete it. So now as part of level 3, so we got these 3 elements. Now if you closely see, when I am at level 3, so I can only from 2 I can reach index 8, from 4 I can reach index 6. Okay, so this is my level 3. Okay, so because which are already been solved earlier, so that from 4 I reached index 6, from 2 I reached index 4. So this is my third path, 1 2 3. Now when I am trying to traverse this, so first I pop 8. 8 is equivalent to my array dot length, so that you already find out a shortest path, so that you can return the shortest path, which is 3. If you don't return it, what could be the possible result? Okay, so let's go on to 6. So if you go on to 6, 6 is not, so 6 is not present in 6. If you go on to 6, if you can move on to the right. So right is what? Having value 16. Sorry, it means right is nothing but 7. Later you can move on to 8. So this could be the longest path, but you already found a shortest path here, so that you can return that path count, which we represent it as 11, so that you can return 3. And this longest path you can ignore. Is that clear, Ajay, Kalyan?
Yeah, sure, it's still. So, basically, when you're processing it, if that index is already end of the list, I mean the length of the array, then we are done with
We are
processing.
done
We
with
don't need to
processing,
go.
right? So we don't, but if you try to look for other element, right, it will give longest path. So we don't actually,
Longest path.
yeah, so we don't need to
Hmm.
worry about this. So that's what I'm saying. So when you go with BFS, right, target element you always found in shortest path.
So basically in DFS, the problem happened is we are exploring all possible
Yeah, so
options.
we are
That
exploring, we are
gives
trying
time
to,
from, yeah.
yeah, we don't know. If you get into this direction, you could find it. But somehow, instead of this direction, if you pick up other direction, right, then you don't find it,
Hmm. Makes
right?
sense. Yeah.
So you get some
Yeah.
value, you get some value, and if you try to explore other direction, in other direction which is already solved as a max value, you get that value because we are maintaining in the DP array, right? If the problem is already solved, you will return that value, right? Is that clear? So let's say
Yeah,
you
sure.
are,
Yeah.
yeah. So let me. What is the time complexity here? This is very tough BFS problem. That's why it's marked as hard, but it's worth to discuss. What is the time complexity, please? How many times an each element can be visited?
It can be visited based upon its number of frequency in that array.
Of course, we can even here the frequency is 3, right? For 0,
Yeah.
for 20. The next time, how many times it visited?
As
You see,
denote the
135 never
index
been
only.
visited again, right? 135 never been visited again, right? If you closely see, 135 visited here. First time we
Only
add,
once.
second time we
Only
pop it, and we never been
Only
visited it
once.
again. Why? Because we
And
deleted associated element from the map so that we don't end up solving the same problem. Okay.
Correct.
So
Order of
in
n.
worst
order
case,
of
it is going to be 2n. So you can say n. So what is the space complexity?
We just took a map.
Map and q also, right?
Q also.
So it's not. It's approximately
n.
n. So map and q. Okay. So uh, this is
Actually,
really,
do we need to take a visited array again
we don't
to
need, right?
track whether
Because
not need
we are handling through
removing it
map,
from the
right?
map?
Yeah,
Yeah.
we are handling through map, so that we don't require. Okay. So let me write the code.
If we don't take a map and try to go with the array approach, we'll
Yeah.
have the time issue again
So
because we
actually,
have to visit every.
yeah. So that's what I did earlier. Okay, I will show that
You
code.
faced there.
Yeah, that's what I faced earlier. Then later I realized it by looking at the test case. So what is our job? So we will have map and integer and list of integers, which is going to be the indexes, right?
So similar. Yeah.
Okay. So now our job is what? First we fill the map. Actually, we are solving hard problems. That's why you feel little tough, but don't mind it. If you solve medium or normal problems, you feel DS is very smooth. But if you learn something from it, it will be very much useful, right? This is hardest problem I ever seen in BFS. So I didn't solve this problem earlier, but by looking at it, I could solve through DFS, but I wasn't able to do it. Then I understand the root cause. Then when I try to solve with BFS, then I end up with time limit exceeded. Then later, actually I've been through article. Then I understood that that's the mistake I wanted to. Okay. Okay. So let's do that. So what are we trying to do? So we are trying to map dot get or default of given index, right? So what is that index? With this value, so you have array. So with the array index, if you have a list already, you get it. Otherwise, you return array list. Okay, so what is our job? So you will get a list. So once you have a list, you can simply add list dot add of index. Okay, then you will just add map dot put of for this element. This is the list. Actually, these problems I should discuss after the graph, so that it was very, you could have connected directly. But I think, hope you are able to understand. Is it going complex or it's fine, Kalyan, Ajay?
It's fine, Shrinu. I mean, we felt it difficult, but with repetitive explanation with different examples, it's clear.
True.
The most important on Q and DQ, right? Most importantly, we get an infusion, and we also write the code, and it also gets submitted, and we don't have confidence that how it is working. So if you are not clear about whole concept, right, then you won't be confident. Do you get me? Yeah, so this is q dot add 0, so I am at level 0. Okay, so I'm at level 0. Now let's move on. So this is my q dot, if q is not empty, you will process. Let's look at it. So what I'm doing, if you closely see, at each level I am considering whatever elements present in that level, I am considering as a single unit of processing, right? Yes or nobody? Yes or no? 135. I am considering
Yes.
as a single unit. I am considering it as a level 1 only, right? So it means level 0, I have only 0. So first what I will do, how do I know that? So I just get first level size. Okay, so first size, okay, is it fine to have levels? Okay, level size, which is going to be q dot size. So this is my current level size. So I need to process this level only. So level size greater than 0, and level size minus. Okay, so I need to process this. So before processing this, what should I do? First I need to take first I know whatever element, so which is present in q, I will just take that. So this is my index, so index equal q dot pool, because I am adding indexes to the q, because I want to, as per the condition, it is I plus 1, I minus 1, and so on, right? So that's why we need to do that. And if you closely see, if so one is I plus 1, so we need to track three cases, right? So one is I plus 1, other is I minus 1, other is array of I is equal to array of j, and I not equal to j, right? So these are the cases, right? So first let's do that. So let's do that. Okay, first one is I plus 1. So we need to solve I plus 1. So to solve I plus 1, first I should know whether the I plus 1 present in the map or not. If it is present in the map, then only I will add to the queue. Okay, so how do I know that? So in the map, so I can say int next element, so which is array of I plus 1, right? So I need to see whether it is present in the map or not. If map contains key of next element, it means I can consider this element. Yes or nobody? Yes or no? Please.
Yes.
So that q dot add of I plus 1. Okay, here I means index. Let it be I. Okay. Okay, I means index here. Okay. So now similarly, I need to consider for I minus 1 also. If q map contains previous element, okay, so how do I know that? I'm just making it more descriptive. This is I minus 1. So if it is previous element, add previous index. Okay, so till now it's fine. Now it's time for me to solve AR of I equal to AR of j. It's time for me to solve it. Closely understand, buddy. Okay, so closely understand here. So okay, Okay, let's take that. No worries. Okay. So AR of I equal to AR of J. So I need to solve this problem. So how do I solve it? Simple. So um, I will get indexes. So index J, right? So I will get J from map dot uh, get of this AR of I, right? Yes or no, buddy? Yes or no, please? Yes or no? This you will return, right? So now
Mm.
if my I not equal to J, then I can add this element to the cube, right? Correct? Till now it's clear?
Yes.
So once
Yes.
it is added, it means you are adding current element. You are adding current element. It means this ith element you've been added to the queue. Whatever possible solutions you could find, you are being added to the queue so that you can simply remove from ith element from the map. This is most critical part. If you don't add it, and I plus 3 element, I minus 2 element, if it is I, then it's keep on populating it. Is this clear? Line number 40 is clear?
Yes, sure. No. Basically removing that one,
Yeah,
the list
removing.
from that, because yeah.
Yeah, so we are just removing from the map. So once you are done with current level, right? So definitely you are promoting to the next level, so that just increment level plus plus. And what is the most important condition we missed it? So the most important condition is whenever you get a I from the queue, right? If it is equal to array dot length minus 1, then you can simply return level, right? At which level you found, you will just return that level. Understood?
The line number, the map removing is there, no? That we had removed the element itself or the index
That's
itself.
what we did, right? We removed complete element, na, earlier also. We removed complete element, right? It is mapping to the indexes, mapping to the element, na.
Correct.
So when you are solving 0, you are adding 135, right? It
Correct.
means you are adding 35 also, right? So it means you are also, you solve this complete 10 again. So you just delete it. Yes or no?
Correct. Mm.
So that 10 is present at 0th index, means ith index, so that we just removed it. So it
And
means
as you're removing with the value,
yes,
so
because we are
it
adding
just
with the
removes
value.
everything.
Because we are adding with
Yeah.
the value, right? We are adding with the value, that's why we are removing with the value. Clear?
Okay.
You keep on getting next element, previous element, and if it is present in map, then only you add to the queue, right? If you don't delete, it will always present in map. You keep on adding into the queue and you end up solving the same problem. In the same level, you may have 1 lakh elements, and if you try to solve 1 lakh elements, then it will give time limit exceeded.
No. Good.
So finally return level. Let's see our luck. So array index out of bounds exception. Yeah, definitely we need to check, right? So what we should do,
Less than 0.
can I do this? So I minus 1 greater than or equal to 0, and I will just replace with it. Okay, so that I can avoid it. And similarly, I plus 1 less than I plus 1 less than array dot length and array of I plus 1. Okay, so just simple logic. And what else? Yeah, others would be fine. Cannot find value. Map dot get of array of I. Are we not putting every value? We always be putting. So array of I. Yeah. Why it is giving error? Tell me, buddy. Why it is giving error? Tell me, please. This is valid. So if you closely see here, index 3 and 5 pointing to the value 10 only, right? 3 and 5 pointing to value 10 only, right? So when I am trying to solve 3 and 5, I'm again trying to get three directed connections, right? So which is already deleted from the map. Understood? Understood, Ajay? So as part of 0, I have added 1, 3, 5, right? But if you closely see, 3 and 5 mapping to value 10. So 3 and 5 mapping to value 10. So when we process 0, we deleted this data, right? Yes or no?
Yeah, we deleted from the map.
Right, so we deleted from the map, right? So when we delete from the map, and if you are trying to expecting the value when you are trying to process 3, then it will return null pointer, right? So what we should do, if it is present in map, then only you will do that. Okay, so let me add that. If map, Kalyan, you understood? You didn't get it?
Not 100%.
No, what are we doing? So let me go through this. Today's session was very painful for me. I chosen a wrong problem. Huh? So you see here, you are solving index 0 now, right?
Okay.
Index 0 having value what? 10.
10.
Which is mapped to what? 0, 3, 5. Right?
Correct.
So as part of
Correct.
index 0, you added 3, 5 to the next level.
Correct.
Now, once you process index 0, you delete it from here. You deleted
Yes,
complete entry
map,
from
yes.
here. It means
Yeah.
whatever indexes pointing to value 10, that indexes data was not present here.
Correct. So
Now,
when
when
it is trying to get next time, it is saying
Yeah,
it won't find.
it won't
Yeah.
find, so that it will return null pointer.
Okay, got it. Yeah.
So that's why we will check if it is not present, then we will do that. It deserves hard, man. That's it, buddy. It deserves. So what I did, so this time limit exceeded, right? If you closely see, we without depending on map, where is this code? Okay, so this one. So without depending on map, I think I have followed visited concept. So it is ending up same logic I applied, but I depend on visited instead of map. So what will happen when the data is very huge? It's keep on adding the same elements again and again. Then it's giving time limit exceeded for this repeated elements. So this is very huge data. See, even I scroll, it is coming. So last it has 11. So this worked for this case because we add only once, so that way it works. Clear, Ajay? Kalyan?
Yes, it's
Yeah.
clear.
You
It
saw-
definitely needs a good amount of practice and pain and paper. Overall, we understood the concept, but I'm pretty sure we'll definitely forget this after 2 days. So we need to practice this
you
one
must
thoroughly.
practice
Yeah.
on pen and paper. Then only you will get to know this. Let me stop recording.
And for sure, no one can actually solve